So it's different than a water treatment process. Now there are some systems, and the junior design group is aware of this, looking at septic issues where we have on-site wastewater treatment systems. So this would be a home septic system that's not connected to a municipal sewer system. So these individual systems do treat the water and remove a large amount of the BOD, but a lot of the nitrogen and phosphorus can flow through those systems. So we eat corn and we eat proteins. Those proteins are made up of nitrogen and amino acids that contain nitrogen. Okay? They end up in the wastewater as food waste or other waste. And the septic systems, while they remove the organic components, don't do a great job of removing the nitrogen and phosphorus. They remove some of it, but not all of it. That moves into the groundwater. The groundwater connects with surface waters downstream that can intercept. Okay? So then we can have discharges of nitrogen and phosphorus into the downstream waterways as well. And these on-site septic systems within the bay are estimated to be about 6% of the nitrogen load to the bay. As a result of this, there's been a large emphasis putting on trying to remove, where possible, septic systems within the bay. 6% is fairly small, but the advantage of this is that it's a contained system. So while it's only 6%, it's 6% that we can manage as engineers in a way that we can connect the pipe to it, capture that, and then do something with the water, which, unlike most of the non-point source pollutants, we have difficulty doing that. So the big benefit of these on-site waste treatment systems, while there are limitations, there's also the ability to capture that as well. And then if we're going to do that, so Gail, this is where we can actually have to go in and look at the numbers. So we say we got about 75 gallons per person per day. We can look at the usage of these systems based on that loading rate and come up with a given flow rate through a system based on the number of people that use that particular system. And then that gives us a volumetric flow rate of the water. And studies have shown here that the total nitrogen concentration is about 39 milligrams per liter going out of that septic system, what they call the drainage field. And about total nitrogen concentration is 39 to 36 milligrams per liter. So we call it 35 or 40. If we know that, we know the number of people, how much water they have, we now have a mass of nitrogen coming out of septic systems where we can model that number given the facilities, given the number of houses, assumed number of people within a house from demographic and tax data. We can actually calculate this as specifically as we like. Now again, as we talked about in this class, we might not want to get very specific because things change. So if we modeled something for a particular day and time in history, tomorrow that could be different as people move houses, change locations, babies are born, people move, these things change. So keep in mind the number of significant figures.